This is 1.10.33. It tells us a warning light in the cockpit of a plane is supposed to indicate when the hydraulic pump is inoperative. If the pump is inoperative, then there's a probability of 0.992 that the warning light will come on. So it sounds to me like we have some kind of tree diagram like this, where your true state of affairs is the pump is either operative or inoperative. Based on that, the light can either come on or not come on. If it's inoperative, it can come on or not come on. Okay, so it says if it is inoperative, so we go down to inoperative, then there is a 0.992 probability that the light comes on. But it says even if it is working, there's a 0.003 probability that the light will come on. So if it's working, so if it's operative, then you have a 0.003 probability that the light will still come on. And it says you have a 0.996 probability that the pump works. So 0.996 that it works. Now, you can always find the numbers for the other branches by subtraction because each set of branches has to add up to 1. So 0.996, do 1 minus that, you get 0.004. 1 minus 0.03 is 0.997, and 1 minus 0.992 is 0.008. Okay. So we have this. Now, remember, if you multiply along the branches, you get the ands, the intersections. So you can multiply along and get each intersection. Let's first, though, come back and figure out what do we actually want. So it says, if the warning light comes on, what is the probability that is really inoperative? So we're looking for the probability that it is inoperative. And it says, if the light comes on. So the part that we know, or the part that is given the conditional, is that the light came on. Now, any conditional probability formula says you're going to take the probability of the end. So inoperative given the light, sorry, not given, and I just said we have to do the and.
What did you do to my...
Okay, answer. Whisper. Over the probability of what's given, which is that the light is on. So the probability of the inoperative and the light means we would have to find inoperative and light, so we come here and multiply. So 0.004 times 0.992. So 0.004 times 0.992 over the probability of the light. Now, this has to be total probability of light. So how do you find total probability of light? Okay. So total probability of light means you have to find anything that has a light, which would be here, and add them up. So 0.996 times 0.003. So we're going to have both of those and add them up. So 0.996 times 0.003 plus 0.004 times 0.992. Okay. Put all this into your calculator and you should get something. So our total probability, or the probability of what we're looking for, is 0.570. Now you'll notice I didn't actually use Bayes' theorem because I find that tree diagrams are much easier. Now, if you wanted to use Bayes' theorem, you can, because this probability of inoperative given your light, right here, how did we do that? We had to multiply this probability and this probability. Bayes' theorem just says multiply these two probabilities, and that's what you put on top. Now, you will also notice, though, because we had to do this addition on the bottom, that's what makes it look super complicated when you look at the formula. I don't know that I ever want to try and follow a formula that looks like that, but draw a tree diagram, and then it's simple. Because the probability of the end is always what you get when you multiply here. And if you want, say, the probability of light, you find all of the ends that have light and add them up, and that's the total probability of light.